Hello dear students, you are welcome to another series of our lesson on nuclear chemistry. My name is Ibukunolu Ademola and the topic of our lesson today is nuclear reactions. I bet it with you, this is going to be the best experience. So I would like to encourage you to get yourself ready for this lesson. Thank you as you listen. God bless you. Dear student, welcome to the series number 3 of our lesson on nuclear chemistry. Today we'll be looking at nuclear reactions. My name is Ibukunolu Ademola. You are all welcome. Here are the objectives of today's lesson. 1. At the end of this lesson, all the students should be able to define spontaneous disintegration. At the end of this lesson, we should all be able to state the difference between nuclear fission and nuclear fission. And lastly, at the end of this lesson, everyone in this class should be able to state the difference between alpha emission and beta emission. Let us begin with the definition of spontaneous disintegration. Spontaneous disintegration is the natural radioactivity which is caused by the instability of an atom. Let us look at this emission produced from spontaneous disintegration, and we are going to start with alpha emission. Alpha emission is an emission that leads to decrease in the atomic number of a particular atom by 2 and decrease in the mass number of this particular atom by 4. Let us look at this example. We have a uranium with mass number of 238 and atomic number of 92, and after emission the mass number of uranium has decreased to 234 and the atomic number has decreased to 90 from 92, and that led to the production of another atom which is thorium with emission of alpha particle. So what it means is when you add mass number of thorium and mass number of helium together, you get mass number of uranium, and when you add the atomic number of thorium and atomic number of helium together, you get atomic number of uranium. Another example is radon with mass number of 226 and atomic number of 88. By the time the mass number is decreased by 4, it produces thorium with mass number of 222, and by the time the atomic number is decreased by 2, it produces another element with mass number of 86. So when you add atomic number and mass number of helium and thorium together, it will give the mass number and atomic number of radon. And another one is the actinium producing astatine after alpha particle have been emitted. Beta emission is another emission produced from the spontaneous disintegration. Beta emission on the other hand is an emission that leads to increase, underline the word increase, in the atomic number of a given atom by 1, while the mass number of such atom remain unchanged. So the mass number of such elements neither increase nor decrease. So let's look at this example. We have an element thorium with atomic number of 90 and mass number of 234. After emission, it produces another atom with atomic number of 91 and mass number of 234, which means the atomic number has increased from 90 to 91 by 1. And by the time you now add the mass number of this new atom and that of beta emission particle together, that's 234 plus 0, it will give you 234, which is mass number of thorium. And by the time you add the atomic number of the new atom produced and the atomic number of beta particle together, which is 91 plus minus 91 minus 1, it will give us 90, which is the atomic number of thorium. Another example is aluminium with mass number of 28 and atomic number of 13. So producing another atom with mass number of 28 and atomic number of 14. So we can see here that the mass number does not change, but atomic number has increased from 13 to 14. So by the time you add the mass number of the new element silicon and the mass number of beta particle together, 28 plus 0, it will give us 28, which is mass number of aluminum, our reactant. And by the time you add the atomic number of silicon and the atomic number of beta particle, which is -1 and plus 14 together, if you add 14 and -1 together, it will at the end give us the atomic number of aluminum, our initial atom. So we also have another element here, bismuth, and we can see the mass number does not change from 210, and the mass number of the product formed, while the atomic number increases from 83 to 84. So adding the alpha particle and the mass and atomic number of the product form will give us that of the bismuth back. Gamma emission is another emission produced from spontaneous disintegration. This emission occurs simultaneously with either alpha or beta emission. And in the case of gamma emission, there is no change in mass number or atomic number. And to know that it is a gamma emission, the symbol of gamma emission is added to the product form at the end of this reaction. Let us look at this example. We have thorium with mass number of 234 and atomic number of 90, producing another atom with mass number of 234 and atomic number of 91. And for the atomic number to have increased from 90 to 91, it shows that it's a beta emission. Now, how do you know that this is gamma emission? It is by adding the symbol of gamma at the end of the product formed. And another example is uranium with mass number of 238 and atomic number of 92. So the product form shows that the mass number has decreased by 4 and the atomic number has decreased by 2. That shows that it is a beta an alpha emission, I beg your pardon. But how do you know that this is a gamma emission? It is by adding the symbol of gamma emission at the end of the product formed. Nuclear fusion is a reaction in which two or more light nuclei fuse together or combine together to form a heavy nucleus, and with the release of energy and radiation. This reaction requires an extremely high temperature. Let us look at this. Deuterium reacts with tritium to form a mole of helium, 1 mole of neutron, and with the release of energy. And this kind of reaction can only occur in the sun or under stars or other stars, I beg your pardon. So what do you see here? We see small nuclei combining together to form a heavy one. The mass number of helium is greater than the mass number of the two reactants. Another one is deuterium and tritium reacting together to form helium and 1 mole of neutron with the release of energy. So let us look at this example. We have lithium with mass number of 6 and atomic number of 3 reacting with deuterium with mass number of 2 and atomic number of 1. The two of them fuse together to form 2 moles of helium and with the release of energy. Another example is deuterium reacting with tritium to form 1 mole of helium and 1 mole of neutron with the release of energy. So we can see here that the mass number of deuterium and tritium is less than the mass number of the helium formed at the end of the day. So when two light nuclei combine together to form heavy one, such reaction is called nuclear fusion. That is combination of two different atoms or more with small nuclei to form a heavy one. Nuclear fission is opposite the nuclear fusion, and nuclear fission is a process whereby the nucleus of a heavy element absorbs a neutron and then splits to form two other nuclei of nearly equal mass and with the release of energy and radiation. We can see here uranium with mass number of 235 absorbs neutron and then splits into two, and we can see energy is also released in the process. So let us consider this equation. Uranium with mass number of 235 rather, and atomic number of 92 absorb 1 mole of neutron and then produces barium with mass number of 144 and atomic number of 56, krypton with mass number of 90 and atomic number of 36, and 2 moles of neutron with the release of energy. So single element, after it has absorbed neutron, produces 2 other atoms. A single atom splits to form 2 other atoms and with the release of energy. We also have another example. Uranium 235 with atomic number of 92, after absorbing 1 mole of neutron, produces 2 other atoms and 3 moles of neutron with the release of energy. Now, when a single atom absorbs neutron and then splits or splitted to form 2 other atoms at the end and with the release of energy, such reaction is what is called nuclear fission. So fusion is combining 2 lighter nuclei together, while fission is breaking up or splitting of a heavy atom into 2 or more nuclei of nearly equal masses. In our lesson today, we've been able to learn the definition of spontaneous disintegration. We've also been able to look at nuclear fission and nuclear fusion and the differences in them. At the same time, we have been able to also look at alpha emission and beta emission and the difference that exists in them. So that will be it for our lesson for today. Thank you for listening. God bless you all. Here is my email address in case you want to contact me or ask me any question. My name still remains Ibukunolu Ademola. Thank you and bye for now.